Let's talk about solving systems that are not linear. Well, they might include linear, but they include something that's not linear. So the methods that we use that are best would be substitution, elimination, or graphing. So I drew a few examples over here just to show you what might happen. Like if you have a circle and a line that crosses through it, it could have one solution or it could have two solutions. Because notice it could just be tangent to the circle. If you don't know what that means, we'll get to that eventually. And it could just touch it once or twice. So you have to keep in mind there could be more than one solution and sometimes more than two solutions. For a parabola in a line, there could be two solutions, or again, there could just be one, or there could be none. That's always a possibility. And then here I have an exponential function and a parabola or a quadratic function, and they touched once in my picture. So just a few examples to keep in mind, like we can have systems that are not linear or not made up of two lines, made up of a line and something else, or two totally different graphs. So keep in mind we use substitution, elimination, graphing. There can be multiple solutions to the system. There can be none, there can be one, two, and a few times there could be more than two. You never know. So once you solve to get your x's or y's using one of those methods, you plug back in to get the ordered pair solutions. That is a note that goes with substitution and elimination. With graphing, you would get the points together. When you find where they are, you have the x and the y. But for substitution or elimination, you have to remember that your first step is to get x or y, or the x's or the y's, and then you've got to plug them back in to get the corresponding x or y that goes with those points. So let's just look at three examples. For the first example, I'm going to use elimination to show you how that would work if possible. I have x squared minus y equals negative 2 and negative x plus y equals 4. So the first thing I need to do is go ahead and eliminate the y because it's set up in a way that that would be really easy to go ahead and eliminate. Then add together, like we always do with elimination, the remaining terms, but those are not like terms, so I bring them down. X squared minus x equals negative 2 plus 4 would be 2. So now what I have left looks quadratic because I have something squared and something that's not squared. They don't go together. So that means I've got to move everything to one side. And then I could try to solve by factoring, or you might occasionally need like the quadratic formula or completing the square. So I'm going to put x in each parentheses. What will multiply to give me negative 2 and add up to negative 1. So that would be negative 2 and positive 1. So then set each factor equal to 0 to solve. So I would get x equals 2, because if I add 2, x is by itself, so x equals 2. And I get negative 1, because if I subtract 1, x is by itself, and it's equal to negative 1. Now notice I have my x values. I need to go back to get the y values. So you want to go back and plug them into the equations that is the easiest or the simplest to plug it back into, because it doesn't really matter which one you plug it back into. So clearly my linear function, the second one, would be the easiest one to plug things back into. So I'm going to plug in 2 for x. So negative 2 plus y equals 4. So that would be, if I add 2, y would equal 6 when x is 2. So that would be the coordinate 2, 6. So that's one solution. And then I'm going to plug in x equals negative 1. So negative 1 plus y is equal to 4. You can use that same simple equation to plug it back into. So 1 plus y equals 4. I could subtract the 1, and I get y equals 3. So when x is negative 1, y is 3. So those ended up being my two solutions, solving by elimination. So I had to get the x and plug each one back in to get the y that it goes with. Now let's look at another method. For the next one, I'm going to use substitution just to show you another way that you could solve. So I have x squared plus y equals 1, and I have 2x plus y equals 2. So I'm going to aim to get y by itself in the second equation because that looks like the easiest thing to do. So we could subtract 2x. So y equals negative 2x plus 2. So I get y by itself in one step. I'm going to plug that value in for y in the first equation, the same way we always use substitution. So I'm going to say x squared plus, and then instead of y, I'm going to plug in what it was equal to, which is negative 2x plus 2 equals 1. So I've substituted for y. Then I can combine like terms, but unfortunately on this side there isn't anything I could put together yet. But I could go ahead and subtract the 1, so I have 2 minus 1 would just be 1, and that way I have everything on one side equal to 0. Now let's see if we could factor this one. So we have to find numbers that will multiply to be positive 1 and add up to be negative 2. So that would be x minus 1, x minus 1. So then when I set one of those equal to 0, you don't have to set both equal to 0 since they're exactly the same. We could add 1, so we get x equals 1. So in this case, I'm only going to have one solution, which is fine. I plug the 1 back into either of the original equations. So just pick the one that looks easiest. So 2x plus y equals 2 definitely still looks easiest because that's linear. So 2 times x will be 1 plus y equals 2. So 2 plus y equals 2. I can subtract the 2 and I get y equals 0. So the y equals 0 where x was equal to 1. So my solution would be 1, 0. So using substitution, I could solve. Just remember, you only have an x, and a solution to a system of equations is a point where these two things intersected. So in other words, you need an x and a y to represent that point. Now, let's look at one more example, and it is using graphing, just to show you your last method you might choose to use. So I have an example of a parabola and a line. I've already used my calculator to set up a table of values. You can set up a table of values with your calculator, or you could have plugged in some x's into the original equation to get the y values in order to plot the points. So now what I'm going to do is plot these points and find where they intersect on my graph. So the way you solve by graphing is you have to graph them, plot points, graph them specifically so you know exactly where they are and find where they intersect. All right, so let's start with the parabola. I have 1, 6, so I'm going to go right 1, up 6. 1, 2, 3, 4, 5, 6. Then I have 2, 3, so 2, 3, 3, 2, 4, 3, and 5, 6. So this is my parabola. I know exactly where it is and some good points to look at. Now I'm going to graph the line. It starts at 0, 7, so 1, 2, 3, 4, 5, 6, 7. Then 1, 6, so I can tell that's going to be one of my intersection points. 2, 5, 3, 4, 4, 3, ooh, there's another one, and 5, 2. So then you connect the points to form your line. And using graphing, so if you're a visual learner, this method really appeals to you because it's easy to just see where your solutions are. So your solutions are where these two graphs intersected. So I have a solution at 1, 1, 2, 3, 4, 5, 6. So 1, 6 is a solution, and 1, 2, 3, 4, 1, 2, 3. 4, 3 was my other solution. So I can clearly see there are two places where they intersect, and those are the 2 points that are my solutions.